Hey there, it's Jason Gorman from Codemanship with another video diary entry. Before we get into today's topic, if you're enjoying these videos or find them useful, please like and subscribe and ring the bell for notifications. Okay, so I've been thinking recently, working with a number of teams on this idea of what I call conceptual correlation. That is the correlation between the language of the customer, the language of the problem domain, and the language that we use in our code, the names that we choose for our code. And I strongly encourage teams to write code that, as I put it, speaks the customer's language, has a strong conceptual correlation with the language of the requirements. And one way you can kind of get a feel for that, that I encourage teams to do, is to copy and paste the raw text of their requirements. For example, the text of customer test that we've agreed. Copy and paste that text into a tag cloud generator or a word cloud generator like wordclouds.com, for example. So we can get a really good visual picture of kind of what the language of the customer looks like, what the problem domain looks like. So sort of a cheap and cheerful project glossary or a cheap and cheerful sort of domain model. So we kind of soak in those words, and then we go take a look at our solution code. For example, here's my code for the Guitar Shack, which is what that tag cloud is based on, an exercise that I use with teams, particularly when I'm training and coaching. When we take a look at the actual language, we've got words like product and warehouse, sell, quantity, stock, restock level, calculate, alert, send, etc., etc. If we just flip back to the tag cloud, it's essentially speaking the customer's language. We're seeing those words: restock, product level, warehouse, sales, etc., etc. Those words are coming up. So our code, we could say, has a strong conceptual correlation with the customer's requirements. It's talking the customer's language. And as we sort of drill down into the call stack here, so let's go and take a look at one of the implementations of the stock monitors dependencies there. Same kind of thing. There's a sales history, there's total sales. There's a few things here we could add. There's a start date and an end date, etc., etc. Average daily sales. So again, it's getting a little cluttered here, but it's still kind of speaking the customer's language. And if we drill down a little further, we take a look at product, ID, stock, lead time. So the same sales history, the same names, product ID, start date, end date, so on and so forth. The same concepts are sort of springing up. And as we work our way towards the back of this call stack in our architecture here, we do eventually hit classes that have almost no correlation at all with the product domain, with the customer's language. For example, this web service class here, which fetches objects, deserialized objects from the two endpoints that we use. This has no correlation with our word cloud, really. We just remind ourselves again. And so we would expect that to be the case, because this is about an external dependency. This is about making web requests. And it's not about the Guitar Shack core logic, as it were. And we would hope that it is nicely abstracted away, that we've essentially contained that low correlation in its own class. And in a real architecture, I would probably suggest that it really belongs in its own .NET assembly as well. That each package of release, if you like, should have a strong correlation with the problem that it's trying to solve. And so maybe the web service doesn't belong in this assembly. So it can give you some very strong architectural hints, actually, particularly when it comes to separation of concerns. In the Guitar Shack implementation I've done here, there is a strong separation of concerns. It's very highly modular. And so all of the webby stuff all the web service stuff is very self-contained. It's sort of hidden behind that web service interface. And we might even choose to go further and extract an interface. So let's bring up our refactoring menu and see what we got. Let's extract an interface. And let's just call that iService or something like that. That has a fetch. So we could get really, let's put it in its own file as well. Really good separation of concerns now, hopefully. Let's add that to there. Okay, so we could go through and replace any references to web service with references to this iService interface, for example. And then I could move web service, then move that class into its own assembly. So the iService interface, for example, might be defined in this assembly, and we might define this implementation web service in a separate assembly, and then the client code, for example, the tests or the web service part of this project, this solution, sorry, would then choose to use that particular implementation from that particular assembly. So good, clean separation of concerns, and the language that we use is often a big giveaway. When we don't get clean separation of concerns, we tend to find that we get lower conceptual correlation between our core logic, for example, our guitar shack logic, and other concerns like web services and databases and that kind of stuff. We tend to muddy it with essentially technical architecture or technical infrastructure. And really you want those things to be pulled very cleanly apart, and that means that you should be able to separate off different kind of domain languages, if you like, from each other very, very cleanly. So look out for that. There's an idea that's described in Eric Evans' book on domain-driven design called bounded contexts, which is kind of along this lines about how we can organize large complex systems into these bounded contexts within one context, a bit like a namespace basically. Within that namespace we expect to have high conceptual correlation, and a sort of a ubiquitous language, I think is the phrase that he uses, for that, solving that particular problem. And the language for solving the problem of connecting to web services is different to the language concerned with solving the problem of managing the stock in a guitar shop. So that's kind of along similar lines, and architecturally we would want those things to be very cleanly separated. So there you go, this idea of conceptual correlation. Weirdly enough, about 4 years ago, I did actually throw together a little proof of concept for a tool for the .NET framework. So it doesn't work on .NET Core, but you're very welcome to fork this code and create a .NET Core implementation of this. And essentially what it does is it searches through an assembly, so you give it the file location of an assembly, and it builds a sort of a word, not a word cloud, but a word list, if you like, that could be used to generate a word cloud, I'm sure, from the names that we've chosen in our code, assuming Pascal and camel case naming conventions. And then it also does the same thing from raw requirements text, and I've tried it on some pretty big files. I tried it, for example, on the Codemanship TDD course book, which is 200 and odd pages, and I just ran all of the text through that for something that stripped out all of the noise words and all of the like words and all that kind of thing, and then built a word list. And then statistically compared the two lists, essentially, the words in the code, the names we'd chosen basically, and the words in the requirements, to get this sort of rough measure of conceptual correlation. And you would expect it, hopefully, to be pretty high. So you're very welcome to have to play with this. I issue it with no warranty, there's no support, there's no hotline you can call, but it seems to work. I've just run it now in Rider, and all the tests are passing. So you're very welcome to have a play with it. There is a blog post that kind of describes how to use it, with a link on that GitHub page there. So conceptual correlation is very useful and it's very important. It is important to establish a ubiquitous language, a shared language that we speak, our customers speak, the testers speak, the UI designer speaks, and so on and so forth, when we're describing the problems we're trying to solve. It's important that we separate concerns very cleanly. So when we see code that has a low conceptual correlation with the problem domain, with the requirements, code that's not speaking the customer's language, then that's usually an indication that code belongs somewhere else. You need clean separation of concerns. Okay, well, there you go. That's today's short video diary entry. I hope you're well. Hope you're staying safe. It's all getting a little scary again. But hang on in there, and I'll see you in the next video.